When we have congruent triangles, all three sides are equal in measure, all three angles are equal in measure. We can see here that PQ is the same length as LM in the second triangle because they each have that little tick mark there. We can also see that side PR is equal in length to side LN as indicated by those three tick marks. We can see angle R is equal in measure to angle N, again because that angle looks the same as this one. And we can also see that angle N with three tick marks is opposite side length LM with one tick mark. Angle R with three tick marks is opposite the side with one tick mark. So all corresponding sides that match up and all corresponding angles that match up are in the same location. So triangle PQR is congruent to triangle LMN. The congruent symbol comes from the similar symbol, so the triangles are the same shape and all sides and measures are also equal. To determine whether or not two triangles are congruent, we don't necessarily have to get out a ruler and measure all three sides and then get out a protractor and measure all three angles. There are three pieces of information that if we have them, we will know are the rest of the sides and angles going to be equal or not. So I have three different side lengths in my triangle and I have two sets of them. You can see that in the second one, if I try to get these three side lengths to connect, in order for them to connect, you can see that we're going to have to end up with the same angles in each triangle. If I'm given two triangles and I know that these two side lengths are the same measure, as are these two, and the angle in between is also the same measure, I know those triangles are going to be congruent because in order to create a triangle, that third side, you can see there's only one way that we're going to be able to connect it. It's going to be from there to there, which means it has to be the same length from here to here. And if you compare those remaining two angles, you're going to see in order to get that triangle to connect, those two angles also have to be the same measure. If I know that I'm given two angles and the side length in between them, I know these two triangles will be congruent as well because there's only going to be one way that I can connect those remaining two sides. So it's going to look something like that, and then you'll notice that third angle is going to have to be the same as well as those side lengths. Any other side lengths and I'm not going to be able to connect that triangle. By extension to angle side angle, you'll sometimes see angle angle side. If we know that these two angles in a triangle happen to be equal, the third one also is going to be the same measure because the sum of the interior angles is 180 degrees. So we know that this angle here is going to equal this angle here. So now we essentially end up with angle side angle, similar to what we have in this situation here, where the side length is between those angles. Now, if I'm given an angle, a side length, and another side length, this is my third side length, that does not necessarily prove congruency because as you can see here, I can connect my triangle like that, that's one triangle, and then I can take that same side length and swing it around like this and get clearly a second triangle that is not congruent to the first one. So if I know the angle measure is the same, this side length is the same, and this third side is the same, that does not prove I'm going to have congruent triangles. I can either have a triangle like this, or I can have a triangle like that. And then if I have two triangles where all corresponding angles are the same, these two happen to be congruent, but they're not necessarily going to be because I can make that shape either smaller or larger. So these two figures are similar, but they're not necessarily congruent. So we can prove that two triangles are congruent if all of their sides are the same length, if the angle in between those two sides that are the same length happens to be the same measure, or if the side length in between two angles that are the same measure happens to be equal in length. So side, 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 or think angle in between those two sides, side in between those two angles. So if we have to prove something that involves triangles, we're going to try to first prove that the triangles are congruent. Okay, so we're going to start by marking everything on our diagram that we are told. So we are told TP is perpendicular to AC. So perpendicular by definition means that two lines are going to intersect at a 90-degree angle. So that means TP intersects AC at 90 degrees. So I can go ahead and draw that in there. And then if this angle happens to be 90 degrees, because this is a straight angle, I know this is also going to be 90 degrees. We're told AP is equal to CP. So side length AP, that one there, is going to be equal to side length CP right there. And then we have to prove ultimately that triangle ATC is isosceles. Isosceles triangles have the same base angles as well as the same side lengths. So if we can prove that these triangles are congruent, it will therefore be an isosceles triangle. My justification for this statement is just that information is given to me. So anything that you're told, you can just say that's given as part of the question. Now, we're also given this piece of information, which leads us to this conclusion, but because this is not quite the same as this, I had to provide a little bit of an explanation here. So line segment TP intersects line segment AC at 90 degrees. By definition, perpendicular lines intersect at 90 degrees. Now remember, if we're trying to prove that triangles are congruent, we need three pieces of information. We have a side and we have an angle that we know are the same in each triangle. Is there a third piece of information? There's nothing more given to us, but take a look at the picture and what else do you notice? Well, we can see that they both happen to share this side. So I've gone ahead and marked that on here, and then you're going to take a look. We have a side, an angle, and a side. Is that one of the three things that proves that triangles are congruent? And then make sure the angle that's the same on both has to be in between those two side lengths, in which case it is. So we know those two triangles are congruent. And our justification is what proves congruency between those two triangles. But then go back to what we're originally trying to prove. We have to show that TAC is isosceles. So this tells us that we have two triangles that are congruent, but how do we now know that they are isosceles? So now our final statement is going to say, therefore, this is isosceles, and then how specifically do we know that? So always, you're going to finish off your final statement is going to be what we're trying to prove, and then we're going to say corresponding sides are equal when triangles are congruent. So therefore, in this case, we know that AT has to equal TC. We could have also said corresponding angles are equal when triangles are congruent. So angle TAP therefore has to equal angle TCP. Both of those would show that we have an isosceles triangle. In a proof involving any kind of triangles, we're going to ultimately try to show that those two triangles are congruent. Begin by listing what we know. So we're told AE and BE bisect each other at C. So this is point C. Now bisect means to cut into two equal pieces. So if we take line AE and we bisect here, that means these two pieces are equal. So I'm going to go ahead and just indicate that on there. And then likewise, BD is also bisecting at C. So that means BD is cut in half at C. So that means that BC has to therefore be equal to CD. Now we're also told that AB is equal to ED. So AB is right here. That's equal to DE. So I'm going to go ahead and mark that on here. So let's maybe use 3 lines for that. And then is that enough information to prove that we have congruent triangles? And we can see that it is by side, side, side. So again, we're saying therefore triangle ABC is congruent to triangle CDE. Now, in terms of the given, this is a statement that's just listed. We have to specify a little bit more here. So we know that these two are going to be equal because bisect by definition means to divide into two equal pieces. Now, the final step we need to do is go back. What are we trying to show? Angle A is equal to angle E. Now make sure that those angles are corresponding. So we can see A is between the side with 1 tick mark and 3 tick marks. Is E also between 1 tick mark and 3 tick marks? If so, they are corresponding angles, so they will be equal. So now we can finish this off. My final statement goes back to what we're trying to prove. And I, in this case, have corresponding angles are equal when triangles are congruent. I know that to be true. Now, just a word about this. The reason I used one letter for each of these angles is because here, this is clearly angle A. We're not looking at any kind of exterior angle here or even potentially here. It's just the interior we're concerned with. You do not want to do that with angle C because then we're not sure we're referring to this one, or potentially you could be referring to the exterior ones. So typically we want to make sure that we always go with 3 letters when we're trying to show angles. So this technically should have been listed as 3 letters. Now we also see that angle ACB is equal to angle DCE because these are vertically opposite angles. So there's other pieces we could have potentially brought in if that wasn't enough at this point to determine congruency.